So I'm Riad. Yeah, I'm super happy to be here. So Cubist is, well, basically a bunch of nerds with some industry and academic backgrounds in things like fraud prevention and computer security and programming languages and cryptography. And basically our mission is to build tooling that makes Web3 development safer and much more productive. So I'm going to tell you today a little bit about the Cubist SDK. Yeah, I think it's going to be super cool. So first things first. So the documents are there if you want to take a look. In a nutshell, the SDK makes cross-chain development, well, we'd say sane. It makes it sane by basically separating the application logic from the implementation details. So this means it's easier to get your application right because the SDK takes care of the low-level bits and bytes that are tedious and easy to get wrong. And it reduces the maintenance burden, and it makes it easier to port your application to different providers, whether that's L1s or maybe other services. So with the SDK, basically the heart of your project is a configuration file. It specifies your project's infrastructure in a totally declarative way. So let's see an example. So this is a sample of a configuration file. I'll make it a little bigger. Cool. And so what you can see here is basically you declare what runs where. So you're saying, I've got some contracts. Some of these contracts are going to run on Polygon. Some of them are going to run on Ethereum. And then you also declare things like your bridging provider, which maybe in this case is Axelar. And you declare something like your network configuration. You say, okay, I'm going to run my local development, and this is how that's all set up. So you tell the SDK this, and then that's built into the configuration, but not into the rest of your code. So this means that the infrastructure information doesn't bleed into your on-chain and off-chain code. And that means you can focus on your application's logic. So the result is a workflow that's much cleaner and much simpler. So here's a really quick example. So I'm going to run right now a smoke test for a token bridge application. I'm just going to run the test, and then we'll go through it in detail. And by the end of this session, you'll know like everything that just happened. So I'm going to run this. And what it's going to do is it's basically going to deploy a contract, and then it's going to send tokens from, send a gas token from one chain to like a wrap DRC token on another chain, and then select a random address on the original chain and send it back to, as it says, some lucky random. So that was a smoke test, and it just ran. And if we look at the sort of infrastructure that's going on in the background, and we're going to see more about this later, basically you can see that that execution resulted in some cross-chain calls. So now that I've whet your appetite, I'm going to tell you everything about how this works under the hood, and I'm going to show you some more examples, and including a preview of our Axelar integration, which is coming in the next few weeks. But before we dive in, I really want this session to be interactive. So if you have any questions, raise your hands, yell, let me know. I'll try to hear you. There will be mics coming around, so maybe wait for a mic. But yeah, definitely interrupt me. I want to make sure that if you have any questions, you get them answered immediately. So let's get started. Okay, so the other thing that you've already seen it, but let me show it to you one more time, is if I can type, our docs are here if you want to grab them now or take a look. The code is all up on GitHub. It's open source. It's free. But if you pull it down right now and start building it, you're going to crush the network for everyone. So just take the docs, bookmark them, and build it later. And yeah, let's just hack along together for now. So great. Okay. So the first thing that we have to do here is we have to build the tool. So I've already pulled down all the stuff. So this is the tool repo. This is what you would pull from GitHub. And basically, well, let's see. We're gonna build it. Well, okay, easy. If I can type. And probably this builds quickly because I've already actually built everything. Okay, so it's done. It's built. And now let's actually see what I just did. So Cubist, if I run this command, I get a bunch of different options here. I can generate a new project, etc. So let's dive in. Let's do one. So here's a new project. Let's make one in TypeScript first. So we support TypeScript and JavaScript and Rust as the off-chain language. And we have some templates. So I'm going to work on the token bridge template right now. And this is TypeScript. And what you get then is oops, I wrote it backwards. So what you get after that is you get this, this project that has some contracts, it has some off-chain source, and it has kind of a pre-configuration for you. So okay, there was the TypeScript version. We could also do a JavaScript version. But actually today, to start, we're going to talk through the Rust version, which I've already pulled down and built so that, again, I don't have to rely on the network too much. So that's in Rust Token Bridge. Good. So basically the idea for this is it's a very, very simple token bridge demo. So we have a contract that runs on chain A that receives gas tokens. And in response, there's a contract on chain B that mints ERC20s, wrapped gas tokens, and then you could send them back across the bridge and recover your original gas tokens, right? So pretty simple, pretty intuitive stuff. Okay, so let's take a quick tour here. So okay, so as we saw before, it's just it's a Rust project, so we have like a cargo file and some other stuff. We have these contracts. That's where actually the Solidity lives. We have source, which is where the Rust code lives in this case, and we have the config file. And we're going to talk through all three of those. Those are kind of the main interesting pieces here. So let's start with the contracts. Okay, so there are two contracts here. There's token sender and there's ERC20 bridge. Let's start with token sender. So this is just a normal Solidity contract. It's pretty. It should be pretty familiar. Is that? Yeah, that's more or less doable. Okay, good. So as you can see, we can import from existing repositories like OpenZeppelin in this case. So we're going to inherit from the OpenZeppelin owned contract. And then this contract just has, it's very, very simple. It has three functions. It has a constructor that sets up some internal state. It has one function that handles sending gas tokens across the bridge and minting ERC20s on the other side. And it has a corresponding function for when the other side initiates a transfer and this side has to release gas tokens in response. Okay, so relatively simple. There's something a little bit fancy in the bridge send in that we take a small cut, right? So this is set up to take 0.1% of whatever's sent across, but sure, okay, fine, that's relatively simple. But I think the thing I want to really draw your attention to here is this call. This is a cross-contract call, this bridge receiver.bridgemin. It's just a Solidity function call. There's nothing special about this. You write it as if you're writing all of your contracts on the same chain, right? So if we go look in ERC20 bridge now, what we'll see is there's a corresponding bridge mint function that is just, it causes it causes minting of some ERC20 tokens. So in a little more detail, okay, again, we're inheriting from some existing repositories, in this case, the OpenZeppelin ERC20 implementation, right? So we are a subclass of that. Our constructor sets that up, and then we just use the OpenZeppelin mint call in response to the call from across the bridge, right? So, but again, when we call back the other way, when we want to send tokens back to the other side, we just call a Solidity function, bridge receive, that invokes the other contract. Okay, so from the programmer's perspective, you are writing as if all of your code runs on one chain. It's really easy to think about. It's really easy to reason through how your contract will behave. Okay? Okay, cool. So now next let's take a quick look at the config file. So we saw an example. This one's a little more complicated. So this one has, a little more content to it. So this is a Rust project. That's what this first line says, right? And then we have some, some details. Then we get to these lines here, which define the contracts and where they run. So we saw ERC20 bridged, and according to the config file, it's running on Polygon. And likewise, token sender is running on Ethereum. Okay? And then we have bridge provider. In the last version, we saw Axelar. Cubist here just means the Cubist trusted relayer, which is mostly just used for local testing, right? And then we have, in this case, we have two different network profiles. So this is kind of nice. I can set up network profiles in my configuration, and I can run, test, do whatever, switch my network profile, deploy to the other network. So later we're going to do that. We're going to switch to testnet and we're going to actually deploy these things. But for now, what you can see, a couple kind of useful pieces here. So first of all, Ethereum and Polygon local nets, okay, that's pretty much self-explanatory. But for the test nets, this is one of these like classic dangers of like checking your authentication tokens and whatever into GitHub. So here we have the ability to pull in from the environment, say from somewhere in your home directory or something, all the secrets that you need. So you can see here that I have my Goerli API key and my private key, and likewise from Mumbai, and those are stored outside of the repo. But when I run, the SDK knows where to find them and can insert them for me. So there's no danger that I'll check in secrets or something like this. So it's super easy. The default thing to do is this, and in fact, I believe it's actually like in some sense it's simpler to use the environment file than it is to like tell it no, what I really need is to use this hex string. You can do that, but like this is the default. The easy path is the safe path. So trying to prevent us from shooting ourselves in the foot. Okay, and then finally I want to just quickly show you a small taste of the off-chain code. So what we saw before, remember we saw that smoke test where it deployed and then like ran one round trip. So that's what this file does, is it's basically just a little test. I'm not gonna show you the whole thing. There's a bunch of just sort of gory details of like calling contracts. Oops, it would be easier if I built first because then it won't give me errors. We're gonna come back to this. So the important thing that I want to note here is, so again, this is kind of simple. We deploy and then run a quick round trip and test that everything kind of happened correctly. But the thing I want to draw your attention to is these lines here, because this is the deployment. Like this is the entire deployment taken care of for you. So it's 3 lines of code. In this case, it's actually possible to get to 2, but it's like 3 function calls to deploy everything. And the comment here kind of hints at what's going on, but I'll explain it in full. In essence, what's going to happen is, we kind of deploy the pieces that we need on each side to actually make the interconnections work. And then once we do that, we actually deploy the user-specified contracts and connect everything up so that all the ownership is done correctly for you immediately. So there's no like deploying and then changing the permissions and all of this. It happens once and it's done. Okay. So so that's as much of the Rust code as I want to dive into. We'll come back a little bit later and see a little more. But now I want to actually show you like, okay, how is that all possible? So why is it that we can do this thing where like immediately you can just sort of run 2, 3 function invocations and deploy your whole app and get everything kind of working for you? So we've already seen this a couple times, but I'm going to run Cubist build, which builds the whole project. And now let's just analyze what's going on in this, in the printout here. So first, the SDK actually analyzes your code, the Solidity code, to understand which contracts are calling which other contracts. So it builds up this sort of graph of the topology of your application. And then based on that and your configuration file, it generates all of the interconnecting code, all these, what we call them shims. These are the contracts that actually handle the interconnection, and they present to your contracts on each chain the APIs that contract expects. So for example, token sender was calling ERC20 bridged. The Cubist SDK generates a shim that exposes the same API that ERC20 bridge does, but only for use by token sender. And so this means that token sender, as far as it can tell, is just calling a contract on the same chain. And that contract is where all of the sort of messy cross-chain logic is happening. Okay, so once we've done that code generation step, then the next thing is just to compile the contracts in the standard way. This is using Solsi. And then finally, and this is the other piece that's really cool, we generate what we call an ORM interface. So that's by analogy to databases, object relational mappers, right? So the idea here is basically, this is, in this case, Rust code, but it could be TypeScript or JavaScript code that understands the topology of your contract and so is able to provide you with these really streamlined functions for deploying or for hooking up the authorization configuration. So this is based on, again, on the analysis of your Solidity code and on the configuration file that we just saw. Okay? So that's kind of what's going on under the hood. I'm going to run it one more time, and I'm going to just sort of manually take you through a couple steps so that we can get a little better idea of how this thing is working. So we do Cubist build. Okay. And then I'm actually going to start the chains over here. So when I run Cubist start, it looks at my current network configuration and it launches everything that I need in order to actually use that network configuration. So I told it I'm running local nets for Ethereum and Polygon. It launches those, gets everything hooked up, gets all the credentials installed as they need to be, and then it's ready to go. And in addition, there's the sort of Cubist sort of trusted relayer that's ready to relay information between those two chains. So that's all set up. Cubist start, you're done. Okay? And then now I'm going to actually, just for my for ease of typing later, I'm going to make a quick alias here. So we have this CLI binary that's also written in Rust. And so when I run that, it has a few options. And those options are basically like deploy the contracts, check the balances, and then actually invoke the functionality. right? So let's just do that, right? So let's deploy, okay? And it's going to deploy, and it tells me, great. So I deployed something to Polygon and something to Ethereum, and it's done, okay? Deployment is done. Okay, and then, well, let's see. Let's see, for example, the balances. They should be nothing right now. Okay, so yeah, there's a bunch of money in the one randomly generated test account, and then otherwise there's nothing. So I can actually like now exercise the bridge. So let's buy a small amount. That's 1 micro ETH. Okay, and now if we look at balances, we see that, okay, so what happened? So the token sender contract took its cut, that's 0.1%, and the rest ended up as ERC20 contracts on the other side. Okay, and so now I can send it back. In the same way, I can just do, well, in this case I have to sell a little less. Okay, so now I'm sending it back, making a call, and my balances are, back to what we expect. Okay, so that's the interface. What was going on behind the scenes? Well, if we go back to, this is the sort of test runner, the Cubist start thing. We can see that each time I made one of those calls, the buy and sell calls, the result was a cross-chain call that was just handled in this case by the Cubist trusted relayer. But so when it was a function call that happened on, say I think it was Ethereum, that resulted in a message being emitted to be sent to Polygon. The message was sent by the relayer, and it appears on the other side. Okay, so there you go. That's how it happened. Okay, great. So let's dig in a little more to some of these details now. Okay, so so the one thing I mentioned a couple times, these shims. Let's take a look at one of the shims. So we generated these shim contracts, and well, they're easy to find. They're in build. In the build directory, we have a subdir for each of the chains. If we look in Ethereum contracts, we have ERC20 bridge.sol. Okay, so this is a contract that the SDK generated. And the first few functions here are basically just handling the authorization stuff. The interesting one is this one down here, bridge mint. So this is a function whose API or whose function signature matches the bridge mint function on the original ERC20 contract. But this one just takes those arguments and turns them, in this case, into an event that the relayer will pick up. But if we decide later, as we're going to see, to use a different bridging provider, then this is the only thing that changes. This shim changes, but your code doesn't need to, because your code is just interfacing with the shim. So this is the idea. We abstract away what the shim is doing and make it seem as if it's just a function call. Okay. So cool. Let's take one more look now. Right. So actually, maybe real quick, I want to show you. I want to show you just for completeness sake the ORM. I mentioned that we generate these ORMs. So it's not the most beautiful code, but basically it's a bunch of auto-generated Rust code that kind of, again, builds in the structure of your application so that all of the function calls that you need to make, for example, to set up the authorization are super easy. One function call and life is done. Okay. So far it seems like it wiggles. We kind of understand what's going on. When you build, it generates shims, it generates the ORM, and then interacting with the ORM is like very chain agnostic. There's no logic built into any of the code that you write that is specific to a chain. So that means we could switch around Ethereum and Polygon, rebuild it, it would be good. But okay, so how about testnets? Well, good. Let's take a look. So let's take a look at the config file. Remember, we had this network profile, and right now it's on local net. So if I change this to testnet, and assuming my network configuration is okay, then I should be able to just rebuild and deploy it to the testnet, right? So let's do that. So first thing we want to do is Cubist build. Okay, and again, we've generated the shims and the ORM. Okay, and now we're going to once again start up the relayer. This time, it doesn't actually have to run any local chains because we're actually using, now we're going to be using Alchemy for this. But so this is we've got this ready to go. And now I can just run that smoke test one more time that I ran before. This time it's going to take a little longer because we're actually interacting with the test nets. So in the meantime, so this is going to deploy, and okay, it's going to take a little bit. But in the meantime, let's take a look at another example. So while we're waiting for this thing to finish, I want to show you one more. So this is kind of like the hello world of cross-chain code, which is to say just a storage contract. So this is a contract that receives a value on one chain, sends it across to the other chain, and it's updated there. So you have like two contracts whose state is coherent. And this is like the absolute simplest thing you could hope for in like a cross-chain bridging scenario, right? Okay, so this one is a TypeScript project. So if we look at the config file for this one, you'll see that it's a TypeScript project, but basically everything else is the same, right? So TypeScript. Otherwise, I have some contracts with their corresponding to certain chains. In this case, again, Ethereum and Polygon, and I have my localnet and testnet configs kind of as before. Okay. So now I can build this. Well, first I have to yarn install, make sure all the Dapps are there. I hopefully have already done it. Looks like I have, good. And then we can Cubist build. And the process is basically the same. It's going to generate the shims, generate the ORM. This time it's using TypeScript to generate the ORM. Okay, and then I'm going to invoke yarn build to actually build the TypeScript code. Okay, and then now again, I can start the kind of Cubist. Remember, I'm using localnet, so that means we're using the Cubist trusted relayer, or at least for now we are. So I'm going to start this, and now I've got Ethereum and Polygon running, and you'll notice that they're on different ports because I have the other ones still running. Good. So then we can deploy, and we're going to deploy with an initial value of 42. Great. So this is it. We've deployed to both chains. Everything is set up. All the authorization is already set for us. And then we can see what value we have. So I have a little script here that just retrieves values, and you can see they're coherent. And we could store something else. And then, of course, retrieve that. Cool. All right, so we can store and retrieve values. Hello, world. It kind of works. Okay, so but now, what if I want to use Axelar as my relayer? Well, okay, that's possible. This is a kind of preview. The current version on GitHub doesn't have this support yet. It's coming in the next few weeks. So all we have to do here is change the word Cubist to the word Axelar. Okay. Now, just go through the building process one more time. Oops. Okay, so we're building. And you'll notice that, well, okay, actually, for now, you don't notice anything. That's fine. But now when we yarn build, actually, no, let's look at the shim first, because that's interesting. So remember before, the shim was just using Cubist local relayer, but this time we've changed the configuration. So now this time, what we'll see is that now we're actually, so again, we have kind of this boilerplate at the top to handle all the authorization stuff, but now you can see that we're importing the Axelar interfaces, right? So at the bottom then, where before we had the cross-chain call just sort of emitting an event, now when I make a cross-chain call, what it's actually doing is talking to, we're actually calling the gas receiver pay native gas for contract call. So that's the Axelar contracts function that is now sort of called immediately by the shim in order to pay for the cross-chain call, and then it actually makes the cross-chain call, right? So the shim kind of handles the details for you. All you have to do is change the configuration file. Okay, so I've already built it, but, oh no, yarn build, good. And now once again, let's just start the machinery. But now this time you'll see it actually started up the Axelar relayer because I told it, I wanted to use Axelar. And then I can call a slightly different function this time just because I have to pay Axelar. But this is, my fault. Okay, and so now if we take a look, the Axelar relayer got this call contract function call that actually made the cross-chain call. So that was all we had to do to switch from using a local relayer to using Axelar was one line in the config, rebuild, and it's done. Okay, cool. So I guess the only thing that we have left here that we're still hanging on is what is going on with these guys. So, okay, so this actually finished. So this was, remember, the token bridge deployment that we did to Mumbai and Goerli. And well, let's take a look, because I have have the scans up. So you can see about 4 minutes ago, there were this sequence of transactions, contract creation. So why do we have two contract creations? Because one of them is the shim and one of them is the user contract. Okay, and likewise, if we look on Mumbai, or sorry, this is on Goerli, we have something similar, right? We see we have a couple contract creations. That's the shim and the user contract. And then we actually ran the thing, we exercised it, and so we see the function calls. And let's take a look, because remember what we do here is we actually send across the bridge, and then when we send back, we actually just choose a random address and send some ETH to that person, just because that's what the test wants to do. So let's see, because that should have arrived. So if we look on Etherscan, I think what we will find is that some lucky soul has received a tiny bit of testnet ETH, which apparently now is worth like $1. So good. So we deployed the whole thing to the testnet just by changing a configuration file, and then actually it ran. So now we've touched the world, and well, the result is our contract is up and running. So cool. I have just about 3 minutes left. That's about all I wanted to show you, but I'm happy to take any questions. If there's anything that you're interested in, like future features, if you have suggestions for things we should support, we'd love to hear that. But yeah. Otherwise, I will just one more time flash up the our website if you want to go take a look. Yeah, so the docs are there. The docs are, we spent a lot of time writing docs. We hope that you'll enjoy them. And yeah, the code's up on GitHub. You can play with it. You can do everything that I've done today, except for the Axelar part, but that's coming very soon. So. Okay. Well, thank you very much for your attention. I really appreciate it.